reiterating, if x, okay, to reiterate things, if x is a normally distributed random variable with mean mu x, variance sigma square x, then x minus mean x upon the standard deviation of x is a normally distributed random variable with mean 0, variance 1. Yeah? Mean 0, variance 1. Right? And this distribution has a name. It is called a standard normal distribution. For the standard normal distribution, alpha and beta will be fixed. Right? So if this is the standard normal distribution, and if you want an alpha and beta which will contain 95% of the distribution, right, then this alpha is 1.96, this beta is plus 1.96. Because now these numbers will be fixed, because the mean is fixed and the standard deviation is fixed. Right, so these numbers are minus 1.96 plus 1.96. Okay, now a little bit more algebra. Okay, is this clear?
So this minus 1.96, this will be constant.
This will be constant because you see, what is alpha and beta depend upon what the mean and the standard deviation are. If you fix the mean and the standard deviation, these alphas and betas will get fixed. So once you're fixing the mean and the standard deviation, see, you got a hat, right? So think of a fireman's hat, right? Okay, sure? Now, if you fix, if there is a regulated size of the fireman's hat, right? And if you put that fireman's hat on a fixed point in the table, so if you drive a stick, nail it goes into this, then this part, the points which will contain 95% of the fireman's hat will also remain fixed. Right? These points will change only if either you change the location of the fireman or if you push the fireman's hat so that it becomes more spread out. But if this is fixed by the fire department and if this is fixed by you, then these will remain fixed. So once you fix the mean and the variance, these alphas and betas will have to be fixed. They can be shown to be minus 1.96 plus 1.96. Right, so if you ask R, find the point, if you have a normal distribution mean 0 and standard deviation 1, find the point which contains such that the area to the left of it is 5%, then you will get an answer minus 5, is 2.5%, because you will get 5%, right? Minus 1.6 plus 1.96 contain 95% of distribution. So just to sort of show you how it works here, okay, just to sort of give you a better idea.
So that is N01.
Mean 0, standard deviation.
That is mean.
Yeah. The first part mu x is mean. And the second part is, alright, so just to show you.
So what is exactly the 1.96?
Minus 1.96 plus 1.96 are the values of alpha and beta, values which will contain 95% of the distribution in the mean. I'll tell you how you can find those values. Those values should not sound mystical.
What about error type 1? Will not be.
Will be there, but they will not be type 1 unless you are testing some hypothesis. No?
This is generalized.
This is generalized. Unless, if you are now classifying elephants, then there is a type 1 or type 2. But this is generalized. Right, so let me now show you the generalized. Okay, so I take this. So let x be our norm. Yeah, let x be our norm. Yeah, x is this, our norm. Normal distribution mean 0, standard deviation 1. Right? And say if I do plot density x. Okay. This is the probability density of a standard normal distribution. Now, if you want a value, you have to find a value such that 2.5% of the distribution. See, previously what did I do? I drew a line and then found out how much the distribution is to the left of that line. On the other hand, I can reverse this question and say, if I fix the area of the distribution to the left, and then at what point will the line come? At first the line is said a line at -10 and said about certain percent of distribution to the left of it. If I say, on the other hand, if I say 1%, then at what point will the line come? Right? Okay, so let me find that question. Let me tell you how to solve that question. Such a question is solved by the command quantile x, okay, 0.025. I might have got the syntax wrong, okay, I hope not. So minus 1.96 is a value, so that 92.5% of the distribution of x is to the left of minus 1.96.
So you're shifting the
No.
curve a little less.
I'm not doing anything. I've got the distribution. I'm asking you, if I have to draw a line on the x-axis such that the line cuts off the 2.5% of the distribution to the left, where should I draw the line? And that answer is minus 1.96. For a normally distributed random variable mean 0, variance 1. Right? So if I draw this line, okay, so if I draw this line, so if I have this, okay, so if I have this quantile, okay, and if I say lines, I want to draw a vertical line, quantile x 0.025. So this will draw a vertical line at quantile x. So if I do this, what it will say is, where is the line? X, oh yes. Abline, quantile, x, plot density.
Abline is not.
Oh, no, abline. Yeah.
Abline.
Abline, yeah, that's the command. Run the line, thanks. So I have this line, which says, so if I want to draw a line on the x-axis, which will contain 2.5% distribution to the left, the line happens at minus 1.96. Right?
So
So it's a
2.5.
point on x-axis.
It's a point on the x-axis.
So 2.5% you have assumed it yourself? Or
Yeah. No, I can change this number. So
as
if I,
per the question.
yeah, suppose I change this number to say 5%. Right? Okay? And say if I ask R2 what that quantile value is really, because quantile x 0.05, right? What will that value be? So if I did this, I will put in one more extra bracket. I think so. Quantile x, right? That is minus 1.64. So if I do that line, so that 5 is to the left, that line will happen at minus 1.64. Right? So minus 1.64 is called the 5% quantile of the standard normal distribution. Minus 1.64 is called the 5% quantile of the standard normal distribution. Now suppose if I wanted to draw a line such that 2.5% distribution was to the right of that line. What kind of a command will I have to give here?
97 point.
Perfect. So this will become 975. Because if 2.5 is to the right, 97 has to be to the left. Right? And let me make this. Yeah? So that value is 1 point plus 1.96. Yeah? And you get this as, if you draw this graph, you see plus 1.96. It's a symmetric curve. Right? Everyone understand this? Okay? So the idea, so if I wanted to get the 50% quantile, what will I do?
Towards
What will, so tell me, what is the 50% of the quantile? Where will the 50% of quantile be?
Middle.
Mean. It's a symmetric curve, so it will be in the middle, right? Where will it be? At 0, because 0 is the mean of this. Right? So if I did this, 0.5, okay? 0.5. Yeah? This is called a median. The median of a distribution is nothing but a 50% quantile. So the area to the left of the median is 50%. And area to the right of the median. So median is a point which divides the graph. Because the symmetric curve, the mean and the median are the same. Right? Sure? Okay. So idea of a quantile is clear to everybody? Suppose I wanted, so what is it, what will I get here? If I do this, so tell me what do you mean by the number that is now risen? What is the number minus 1.036089 represent?
So 15% on the left.
Yeah, so 50, it is a value
Probability.
such that the probability that a standard normal random variable takes a value less than minus 1.03 is 15%. The probability that a standard normal variable takes a value less than minus 1.03 is 15%. Right? Sure? Okay, now this is a very important thing. Okay? This is a very, very fascinatingly important item. Right, so I'm going to do some algebra now, right? So please bear with me, but algebra is very important. Yeah, so let me do some algebra. That algebra is going to be very useful for our think of a population. Yeah? Think of a population from which, so think of a population which has some distribution. Okay? Suppose that mean is mu and the variance is sigma square. Some population, I am not saying what its distribution is. Okay? Think of x1 as one random sample from this population. So there is a whole set of households. I pick up one household at random with replacement. Let x2 be another household that is picked up. The first household put back, again all the households are mixed and a fresh household is picked up. Right? Let x3, so I put the second household back again, mix all the households thoroughly, pick the third household, and so on. Like that I have a sample of size n which is now a random sample. So does x2 depend upon x1? No. Does x3 depend upon x2? No. So they are all independent because they are all randomly picked up. Now think of forming x bar. Yeah? Which is summation xi upon n. Now x bar will be a random variable because I can pick another size sample of size n. If I pick up, I'll pick up another n numbers. So I'll get another x bar. And you've seen that picture, no? So I want to now find expectation x bar. Yeah? That is the mean of. I know that x bar will be normally distributed. How do I know x bar will be normally distributed? Central limit theorem. Because it is the sum of n independent random numbers. I sum and then divide by n. So the central limit theorem will ensure that x bar is normally distributed. So if it is normally distributed, what are the two things I need to worry about? Mean and the variance. Mean and the variance. So let me find out what is the mean. The mean can be found by expectation x bar. Right?
Yes.
Is this clear? Expectation x bar is the mean?
Yeah.
Okay. Which is expectation of x1 plus x2 plus x3 plus x4 plus xn upon n, because that is the definition of x bar. Right? Okay. So now from which I have expectation of x1 upon n plus expectation of x2 upon n plus expectation of xn upon n, because expectation of x plus y is expectation of x plus expectation of y. Right? Sure? The next station will be 1 upon n expectation x1 plus 1 upon n expectation x2 up to 1 upon n expectation xn. Everybody understand this? Because expectation of alpha x is alpha expectation x. So 1 upon n is that constant. Okay, now tell me what is expectation x1. What do you mean by expectation x1? $1 million question.
It's just a constant, x1.
No. X1. So what is x1? X1 is the income of the first household in your sample. Now that first household is a random variable because any household could have been chosen as the first household. So if I ask you the expectation of x1, I am asking you what would be the average income of the households which could have been chosen as the first household. Which is nothing but the mean of the whole, all the households. So any household can be chosen as the first household. If any household can be chosen as the first household, then the mean value of the first household which are chosen as first households will be nothing but the mean value of all the households. Ultimately, if I look at say the mean weight of everybody here and I go to average and anybody can be picked up as the first person in that sample. So the mean weight of all people that are picked up as the first person will be nothing but the mean weight of everybody assembled here. Right? So therefore expectation x1 would be the population mean. Yes. Which is mu. So I would have 1 upon n into mu plus this will be what? What is expectation x2? The average weight of the household which could have been chosen as the second household. Any household can be chosen as the second household. Right? So 1 upon n mu, so on 1 upon n mu. So how many times do I have 1 upon n mu? N times. So this becomes n upon n mu is equal to mu. The first thing we know about x bar is now is nominalistic mean mu. Right? So the mean of x bar will be the same as the population mean. The mean of x bar will be the same as the population mean. The next step is, because in normal distribution the second quantity is to find the variance of x. Second quantity is to find the variance of x. Okay. Now how will you get the variance of x? Okay, so now I want to find the variance of x. So variance of x is variance of x bar is variance of x1 plus x2 upon xn upon n, right? By definition, because this is x bar. x1 plus x2 plus x3 plus xn upon n, which is what? Which is variance of x1 upon n plus x2 upon n plus x3 upon n plus xn upon n. Yeah? Now there is a formula which says variance of x plus y is variance of x plus variance of y plus 2 covariance xy. Right, and intuitive to understand this is, we are looking at x plus y. X plus y will vary because x varies, y varies, but if x varies, y also varies with it, then the moment in y will be counted, there will be moment in y, and if y varies, x will also vary, so there will be a co-movement from y to x, so you have to count the covariance of xy twice. Variance of x plus the variance of y, वो x हिलने से y हिलता है, वो variance covariance आ गया, y हिलने से x वापस हिलता है, तो y plus x हो गया, तो 2 covariance x y, right? But if x and y don't move with each other, x and y don't depend upon each other, then क्या होगा? Covariance will be 0. So variance of x plus y will be variance of x plus variance of y. Right? Now all these are randomly chosen. So covariance between them is 0. So this part is variance of x1 upon n plus variance of x2 upon n plus variance of xn upon n. Right? Now what is variance of x1 upon n? What is variance of x1 upon n? 1 upon n square variance of x1, because variance of alpha x is alpha square variance of x. So this would be 1 upon n square variance of x1 plus 1 upon n square variance of x2 plus 1 upon n square variance of xn. Sure? Right? Now what is variance of x1? The variance of the household which could have been chosen as the first household. Any household can be chosen as the first household. So variance of x1 will be nothing but the population variance sigma square. Right, because x1 is the first household. Any household could have been chosen as the first household. That's why it's a random variable. So variance of x1 is effectively the variance of all the population, because anybody could have been chosen as the first household. Right? So variance of x1, that is sigma square, right? So this will be 1 upon n square sigma square plus 1 upon n square sigma square plus 1 upon n square sigma square. Right? How many times I am adding this up? N times. So what will I get? So I get n sigma square upon n. Right? So what we are saying is, if x bar is a sample of size n coming from a population with mean mu and variance sigma square, x bar will be normally distributed with the same mean mu but variance equal to the population variance divided by the sample size. So there is a population which is a mean mu, which has variance sigma square. I am taking a sample of size n and forming a sample mean. The sample mean is a random variable. We have established three things about it. A, because of the central limit theorem, the sample mean will be normally distributed. B, the sample mean will be the same, the mean of x bar will be the same as the population mean. And the variance of x bar will be equal to the population variance divided by the sample size. Divided by the sample size. So if the population variance is 100 and the sample size is 10, the variance of x bar will be 100 upon 10, which is 10. Can you give me an intuitive reason for the second part? Why should the variance of x bar be the variance of the population divided by the sample size?
Is it got anything to do with standard deviation?
No. Standard is the square root of the variance.
Is it because when you are taking like each sample that is not normally distributed, when we are summing it up, then it's tending towards normal?
Yeah, but why should the variance be half?
Then each sample, suppose there are 10
So look at it like this. If there is x1, think of x1, first household, coming from a population from a population with some variance sigma square. So if I just pick one x1, that will have the same variance as the population variance sigma square. Right? If I pick another x2, which will also have the same variance as the population variance. But if I pick x1 plus x2, then x1 is one bit of information about the population mean. x2 is another bit of information about the population mean. So x1 plus x2 has twice the information of the population mean. So its variance will be half the population variance. if x1 is one bit of information about the population mean, x2 is another bit of information about the population mean, and these two are independent bits of information about the population mean, the reliability of x1 plus x2 upon 2, which is 0.5 x1 plus 0.5 x2. So I am actually combining x1 and x2 into another aggregate. I am creating a weighted average of x1 x2, 0.5 x1 plus 0.5 x2. The accuracy of 0.5 x1, 0.5 x2 will be twice that of x1 or x2 individually because there is no double the information.
So we're duplicating the.
Yeah, so we are simply doubling this. If you take a third, so suppose now if I want to know what the time is, okay, suppose each of you have a different time in your watches, right? So if I just take a sample of size 1 and find out what that time is, I can pick up any of you. So the variance of that information which I will get from one sample will be same as the population variance. But now if I ask her the time and if I ask Aniket the time and if I average the two, I have two different bits of information about the time. So my information is twice that in the first case. So if my information is twice that in the case, my reliability also has to be twice because these are two independent bits of information. The information is doubled. So the spread of my estimates around what the true time is has to be now half what would have been when I was using a sample of size 1. So the information is now, because the information is doubled, the variance is half now.
So, let's say in the
Yeah.
example that you've taken, that you asked Aniket and you asked Simran the time. So let's say right now it's 4:10.
That's one estimate, right?
Yeah.
The actual time could be anything.
Okay.
So basically the idea is that there is some actual time